Hey guys, we're going to look at factorizing polynomials. We've done a little bit of this preparation before, looking at the factor theorem and solving polynomials. So now we are going to take it even further, and it's not that much extra work to what you've already done before, especially when we come to factorizing quadratics. So with polynomials, let's say we're looking at degree 3 at this point in time. You'll have a factor, and then you'll end up with a quadratic expression. Once you've got that quadratic expression, you'll factorize that to its point. So let's just start off with this, and we know that this particular example is degree 3 polynomial, and we can work out what a factor is if we were to substitute certain values. So let's say if p of 1, that means 1 cubed minus 5 times 1 squared minus 2 times 1 plus 24. Okay, so we've got 1 minus 5 minus 2 plus 24. This does not equal 0. Okay, so it doesn't equal 0. That means it's not a factor. So we need to think of another value. Okay, and so I guess it depends on, you can do a little bit of trial and error and kind of use your discernment and your judgment on what values you're going to be playing around with. I'm going to try p of negative 2. Okay, so we've got negative 2 all cubed minus 5 times negative 2 all squared minus 2 times negative 2 plus 24. This is going to be negative 8, and then for minus 20, then plus 4 plus 24. Okay, so 4 plus 24 is 28, minus 8 minus 20 is negative 28, so that does equal 0. That means x plus 2 is a factor. So what we need to do is actually then divide this polynomial by the factor we have just found. Okay, so going back to dividing polynomials, feel free to go back to that, otherwise we're going to go through this one anyway. So x squared times x will give us x cubed. X squared times 2 gives us positive 2x squared. We're going to subtract, leaving us with minus 7x squared. Then we're going to take down the 2x, which is minus, and we will need a minus 7x. So minus 7x times x gives us minus 7x squared. Minus 7x times 2 gives us minus 14x, and we'll subtract that. And then that will leave us with 12x. We'll take the 24 down, and we'll have, let's say, plus 12 is going to be the constant. And 12 times x is 12x, and then 12 times 2 is 24. And if we subtract that, we end up with 0. So what we have now is we have x plus 2 as a factor. We have x squared minus 7x minus 12 as the other part. Okay, so that's our quotient. But now we have a quadratic expression that we can further factorize, and this one is a monic expression. Factors of negative 12 that add up to negative 7. Let's think about that. Actually pays good attention to make sure that we've got a positive 12 here. So that will make things a lot easier. So what we have is x minus 3 and x minus 4 as our factors for that. X plus 2 is going to be then our factorized form for that polynomial. Okay, so that's all we need to do. You've got all the tools, it's just putting it into play and stitching them all up together. We're going to move on to another example, and we're going to do the same thing with this one as we did with the other time. Okay, so in this case, I'm just going to jump the gun, and let's say P of 5 is going to be a factor here. Or let's make it minus 5, shall we? So P of minus 5, and we've got minus 5 cubed minus 19 times minus 5 plus 30, and we've got minus 125. Now 19 times 20 times 5 is 100, so then we've got a 95 here, positive 95 plus 30. 95 plus 30 is 125. That cancels out with minus 125. So that becomes 0, which means that x plus 5 is a factor. Okay, so notice that this doesn't have an x squared term. There's no x squared term. So remember when we divided polynomials, what we need to do is actually put a 0x squared. We still, because of its place value, we still need to include it, and put a 0 because it doesn't exist. And then we'll have x plus 5 at the front. So let's divide as per usual. So we'll need an x squared here, which gives us x cubed plus 5x squared, and we'll subtract, which gives us minus 5x squared. Take down the minus 19x, and we'll need a minus 5x to give us the minus 5x squared. Now minus 5x times 5 is minus 25x, and we're going to subtract. Now it's, again, reminder, make sure that your polarities are in place. So two negatives makes a positive, which gives us 6x over here, and we'll take down our 30, and we need a 6. So 6 times x gives us 6x, and 6 times 5 gives us 30, and if we subtract that, we get nothing. So what we're left with is x plus 5, and then x squared minus 5x plus 6 is our quadratic, and we can factorize this quadratic to x minus 2 and x minus 3, because minus 2 times minus 3 gives us a positive 6, and we add these two negative numbers to give us minus 5. So x plus 5 becomes our x plus 5, x minus 2, x minus 3 is our factorized form. Okay, great. So I'm going to finish off with one more example. Okay, what we have here at the moment, we've got P of x is equal to minus 2x cubed minus 8x squared plus 6x plus 4. We can already see that there is a common factor of negative 2 out of all 4 terms. So we first take that out, and we get this left over. And we can then just concentrate on this part because we've already taken the negative 2. What I'll probably point out is that because I've taken negative 2 out, I need to reverse the polarities on all the others. So that should be a positive 4. Okay, this should be a negative 3, and this should be a negative 2. Okay, that's a lot better. So again, remember to make sure that your polarities are correct. It's an easy mistake to make. Okay, so let's call this Q of x. Okay, and we're focusing on this polynomial. And let's just substitute 1, and hopefully that becomes a factor. So 1 cubed plus 4 times 1 squared minus 3 times 1 minus 2 gives us 1 plus 4 minus 3 minus 2. So 1 plus 4 is 5, minus 3 minus 2 is minus 5, so therefore it is. We've got x minus 1 is a factor. Okay? All right. So where we take it now is x minus 1 is going to do the dividing of x cubed plus 4x squared minus 3x minus 2, and we're just going to work out what that becomes. So x squared is going to give us x cubed minus x squared, and we're going to subtract, and we should get 5x squared here. Two negatives makes a positive. Take down the next term, and we want 5x to give us our 5x squared. 5x times minus 1 is minus 5x, and we're going to subtract, and we'll get 2x because, again, two negatives makes a positive. Take down our minus 2, and we want a positive 2. 2 times x is 2x, and 2 times minus 1 is minus 2. And if we subtract that, we end up getting nothing. So what we have here as our factor, x minus 1 outside of x squared plus 5x plus 2. But remember, we took out the negative 2, so we're going to put our negative 2 here. Don't forget it. Now, the next thing is to make sure that we factorize our quadratic expression. Now, look at this quadratic expression here. There aren't any immediately. You can see that it's a little bit tricky. There's no factors of 2 that add up to 5. Therefore, you'll need to complete the square, or you could use a quadratic formula. But in this particular chapter, for this particular time, we're going to keep to integers and not no surds in this point. So we're going to stop here and say that this quadratic expression cannot go any further. Okay, why not? Let's just do one more. And this is factorizing shorthand. Okay, so you've got long division and you've got short division. Same thing with polynomials. And this can be, I don't know, if you can get your head around it, then it's okay. It's fairly straightforward and simple. If you understand your factors and your multiples and knowing what to look for, then you can use this to kind of speed things up. But if you are not so competent and not so familiar, then just go along with the long division and just follow the same process, and you'll get to the same answer. Okay, but I'm going to start off with this expression, and we're going to still work out what the factor is. Okay, so let's say if we had p of 1, and so 1 cubed minus 5 times 1 squared minus 2 times 1 plus 24, 1 minus 5 minus 2 plus 24, we can already look at the string of numbers and it's not going to equate to 0. So that's not going to be a factor. Okay, let's try p of 2. So if we had 2 cubed minus 5 times 2 squared minus 2 times 2 plus 24, we've got 8 minus 20 minus 4 plus 24. It's almost there because the minus 20 minus 4 becomes a 24, but we've got an 8 here, so that's not going to work. So obviously that cancels things out. Actually, what I'll do, is we'll try p of minus 2. So we got minus 2 cubed minus 5 times minus 2 squared minus 2 times minus 2 plus 24. So we got minus 8 plus 20 plus 4 plus 24. Okay, so what we have here, actually it's not plus 20, it's minus 20. Again, the polarities, so my minus 2 squared is positive 4, but 4 times minus 5 is minus 20. That's better. So then you got your minus 28 and your plus 28, so it cancels out. That means x plus 2 is a factor. Okay, so what we'll end up having is x plus 2 and then we've got some form of a quadratic expression that we need to fill in. So this is where the short division comes in. And so for example, just remember with that being dots, sorry, not dots, with perfect squares, you know that we need the first term squared, we need the last term squared, and then we need double of the two terms in between. And when you see something like this, you can go back the other direction knowing what to do. Or if you have something like x plus 2, x minus 2, you know that it's x squared minus 4 because you're familiar with the patterns. So in this case here, I want you to think about what terms. Our first term here is an x cubed, okay? So automatically the quadratic expression inside the brackets needs to be an x squared, because then when you expand it out, you'll end up having an x cubed to begin with. That's how you get your degree 3. Then you need to think about your last term, which is 24. 2 times what will give you your 24 in the end, okay? And that's going to be 12. So we've got our expression here already where we've got our first term of our quadratic, we've got our last term of our quadratic, but we just now need to work out what our middle term is. We know the middle term should have an x, but we don't know what the coefficient is, so we'll call it a, okay? So now this is the step where we need to work out what that middle term is, and this is where you need to kind of put your mind into backtracking or expansion and just trying to figure out what that would look like. And so if we multiplied the 2 with the x squared, we're going to get 2x squared, okay? And then if we multiply the x by the ax squared, by the ax, we're going to get ax squared, okay? But when we look at this expression, the original polynomial, we need these two terms to equal minus 5x squared. So what is the missing coefficient of x squared here to give us minus 5? Well, that's going to be minus 7. Okay, so that means what we need is we've got x plus 2, x squared minus 7x plus 12 as our quadratic or our quotient once we factorize all of this by the x plus 2. Okay, now once we've got to this place, well, you can re-expand everything and you'll definitely get back to your original one. But with this particular video, we're wanting to factorize. So now that we've got our quadratic, we're going to factorize x squared minus 7x plus 12, which is going to be x minus 3 and x minus 4. And then we've got our x plus 2 as our factorized form. There's our solution. Hopefully that helps you guys. If you've got any questions, let me know. Otherwise, I'll see you in the next one.